Thank you very much for coming to my session. So, a little bit about myself. So, my name is Sergey. I came from Cyprus here. And for the last 10 years, I've been working with databases that were tens and even hundreds of terabytes in size, mostly on SQL Server, but not only on these. And what I'm going to talk about today is about this experience. I will share a lot of stories which I came across. So I will specifically concentrate on refactoring topic. So when working with multi-terabyte databases, you need to think about performance, about architecture, scalability, and so on. I will focus mostly on refactoring. So the things, how you can easily change your database so to keep up with the coming workload. So, and I want to know a little bit about yourself. So who has database which is more than terabyte in size? So many of you, yeah. 10 terabytes? Or 50 terabytes? Nice. It's OLTP, more than 50 terabytes. Great. So it's fun to work with such databases because I have three probably points on this topic. So first, if you came across some problem and you Google it, sometimes you even can't find an answer, and you understand that you're the first one who will solve this. So the second point is that you will hit some limits. So for example, you know that it's not the best practice to keep more than one transaction log for your database, but the transaction log is limited to 2 terabytes. And if you hit this limit, yeah, you can have multiple such files. And the third point is that you watch Bob Ward's 500 sessions and found them really practical and can help you. So, so before you start refactoring a huge terabyte, what should you have? My point is that you first need good tools to manage. So I guess most of the people use some kind of IDE for developing databases, not on production anymore. So I found that Visual Studio and DataGrip from IntelliJ so both work pretty nice. So you can easily rename, for example, a column, and it will rename in all the stored procedures also inside this. You can have built-in schema compare functionality that will help you to build update scripts and so on. And sometimes what I found in DataGrip is that if you, for example, rename a column which is mentioned inside a dynamic SQL, so Visual Studio, I haven't heard that will solve this problem, but DataGrip found such problems for you also. So the second thing that you need tests. So because without tests, you can't do refactoring well, so you can be sure that everything will still continue to work nice. And so you better know some features that will help you with smooth refactoring. So for example, for SQL Server, there is a bunch of functionality that will help you. So for example, adding column with null or default value is absolutely free in SQL Server since version 2008, if I remember. So we can use views, because you know there are partition views inside SQL Server. So for example, if you migrate table from one to another, you create a new table, you create a partition view over these tables, you put the check constraints into these tables to separate workloads, and you do a smooth data movement beside this. So you need to know. Another point, anybody use synonyms in their databases? Nice. So anyone use synonyms to get access to an object on another database? Yeah, great. So it's a great way to decouple your databases because you keep the object which you call inside your database, but seamlessly, depending on the deployment, that the object from another database will be called. So, and it's also useful when you, for example, renaming database. You just create a synonym with an old name for legacy users until they switch to a new name, for example. Triggers also, guess many people talk that triggers are awful, don't create them, but I found that even on large tables, they work pretty nice if you do it well. Storage procedures also can be, you can encapsulate one storage procedure in another, so also helps you to change things. And SQL Server also supports transactions over DDL and DML operations that you can smoothly move data, change objects while still having calls for these objects that will be safe. So will be blocked, and after changing, they will accept to a new structure. So all these things will be useful. So, okay, let's start for lessons learned. So before you start refactoring, you should know your customer. What do I mean for here? So you need to enumerate all the user interfaces, all the external access to your database. So you need to define this. Does anyone keeps a list of storage procedures, tables, table variables, which are accessed by the user with SLA, for example, depends. Does anyone keep such list externally? Does anyone knows what kind of interfaces you want? So, yeah. Do you keep it in like Wiki, Excel, or whatever, any kind of? In a table in a management SQL. So, okay, I found that this approach really fails. So if you keep it separately, what I suggest is create tests for your external interfaces. Each interface which is used by the external user should be tested. So the benefit is that you have tests for all the external things. And the tests could be descriptive, how it can be used, what are edge cases, and so on. And it helps, if you change something, it helps you to ensure that things won't break. So, and you should remember that you need to cover tests for almost everything, not for storage procedures only. So if you use table variables, you need to create tests for these table variables also, because what happens if you add a new column or remove a column from a table variable which is used by an external storage procedure? So you need to fix this. So also if you have users access to your database through synonyms, views, or direct table access, which is really not recommended. So again, you need to cover these and fix these, so in case you don't break anything. And that's why you put tests closer to your code, and this approach, I guess, works better than to keep this documentation externally, but because from time, the documentation and the code will go asynchronous. So and remember, no direct access. So if you have direct access for your database, so your refactoring will be really painful, so, of course. So the next thing is I suggest that you do any changes inside your database as smaller as possible. So for example, if you decide to merge two tables into one, so you can split this step into multiple ones. So for example, you can move one column, another, and then only move all the columns, and then drop the old table. Even move column refactoring can also be split into multiple steps. It's like creating new column, sync data, change queries, and drop all columns. Of course, that also creates a lot of extra work, and I don't recommend that you really go as deep granular as descriptive here. Make some balance. So because for performance reasons, of course, it's sometimes easier to move several columns at once and not do this. But the smaller steps, the better you go on production, the faster you change. So, and what else I also came across is, I think that you also, who use some kind of version control for database code. So many of you guys, yeah. So if you put your data in version control and you start to make a change, some like big feature on the purple branch, for example, and you found something small while doing this big new feature, doing something small refactoring which everyone will benefit, my suggestion is that never try to do it in your branch. So create a separate branch, make this smaller change, merge as fast as possible to your master branch. Because usually you came into a situation that you have that small fix, anyone will benefit. On the Scrum meetings, daily Scrum meetings, you announce that you found this. Sooner it will be in the master branch. Everyone will wait for it. And you can block someone else's work. And it also can come the situation that your big feature will not be live soon. So you'll need some more tests. Sometimes the work can be canceled, and this change will just be lost. And so separate, make it smaller, make faster. So the next thing is about deployment. So what I also suggest, so there are a whole bunch of tools right now which will simplify the deployment process. But the solution that works really nice is to create scripts. You can keep your state database in the code as long as you need. It's simple to work, but create deployment scripts in like a version script. So, and to get, for example, to a version 3.1, you need to first run a script 1.0, then 2.0, then 3.0, then 3.1. So you just create a series of scripts. How it helps? So it helps you to, again, to manage how your database was changing. So, of course, from time to time, you can collapse those scripts together, not to have a very long queue of these. But it will simplify deploy. So, how? So, I not recently, a few years ago, a couple of years ago, I came to a situation, for example, that I was using someone else's database as a temporary source, and I was writing code. And they do not produce the version of their database as the series of such scripts. So I took a snapshot of their database, put it into some project, what tables I need, created a script. And when I ran in production in a week or two, with this tool, I found that I started to get errors that the table I'm accessing doesn't exist. So I came to the team and said, oh, okay, we completely changed the data structure in the last 2 weeks. So, and if they have such kind of series of scripts, I can just grab a new scripts from the repository and change my code also. But while they didn't have these, I needed again to go into their database, see what's changed, compare, and then rewrite my application. So, and also such series of scripts create you to helps you to create a bunch of environments where you can test. So, for example, you create changes. So every developer, of course, has Sandbox on their local machine where they create database tests. You have some integration layer, probably some kind of GitLab or TeamCity or whatever tool you can use. So where the changes from multiple developers will be integrated and check that the whole feature works. And then if you have such scripts, you then can have multiple pre-production environments where maybe some real data, on a subset of real data. The applications are tested, some performance testing, some acceptance testing is done. And the scripts, again, deploy scripts are also tested on this environment, that they work nice. And when you go to production, you really have a good script which you just need to run. You can expect how much time it will take, what can be the problems, and so, yeah. You go, while coming to production, you go well prepared. So, and I found that to help all these things, SQL Server on Linux containers really helps on this. Anyone use it? No? On tests, on test environment? This is pretty cool. So, for example, I have also MacBook on ARM chip, and I can run SQL Server inside Linux container on MacBook on ARM chip. So this is possible with SQL Server in Docker. So pretty useful for testing, for creating pipelines and integration tests and integration environments. Not for production, of course. Yes, I never heard that anyone used SQL Server in Docker in production. So next thing that you need to know is that while working with such databases, backup and recovery is also a part of the design of your database. So for example, if you want to have a piecemeal restore, a partially restore to help to lower the RTO for your database, you need to design your queries and your schema well, that your queries can access the most recent data only, which will be restored firstly, and queries that are not important will fail while you restoring the rest of the database. So you also need to take this into consideration. And what I also found useful is that if you have some kind of event log before your database, if you build the system mostly on event sourcing pattern. So it also helps a lot for recovery, and for further I will have examples again on this pattern. So, and also it helps if your database is not relational, for example, not have strong consistency, say. What happens if you have such log? Usually it's nowadays, Kafka is used for this. It's distributed, log, high available. And so, for example, if your database is restored with some data lost, of course, that could happen. So for SQL Server, you have transaction log backups. You can restore up to point of time recovery. For NoSQL database, other databases, you may not have such feature. But if you have a log of events before your database, your application starts, understands that data is missing, and rereads from this log and loads the data automatically inside your database. So you just need to keep like several days of data coming into your in your event log before your database. So, and also for simple recovery, never use long-running queries. That is painful. So never long deletes, never long updates, even if it's simple. So never use this. Always try to use your code like this way. So something like this way. So in controlled and smaller batches. So any update, any delete, any large scale operations should come in smaller batches. So, so let's move to a more serious stuff, which you need to think about. So, about moving columns between tables. So imagine, this is pretty simple example. Imagine you have a database with 3 columns, and 90% of all your queries doesn't use your 3rd column, description column. So it's not a problem. It's not about the size of the table. It's mostly about the memory. So because you use raw storage, the data will be cached in memory all. And if you remove such column to another database, and you do a join. Of course, 10% of your queries that use that column will be a bit longer in performance, but the 90% of all important queries will run faster because you will use more memory nicely. And what about numbers? So for example, if you move only 10% of all your columns to another table, so you will get about 11% of more data in memory. But if you move 35, you will get almost 50% of data, more data inside your memory. And again, it works both sides. So if you have something which is inside other table, and this accessed quite often, consider denormalizing back. And yeah, sometimes I see it's almost becoming 2 times faster, such queries, because you just eliminate 2 tables access, usually. Oh, this is a huge topic about fragmentation also. You also need to think about this. Yeah, we have a question. So.
A question for the columns. Have you had any pitfalls rearranging columns within the table, reordering the ordinal position of the column?
So the question was, did I have some pitfalls when rearranging columns inside the table? So you mean, if I'm quite right, you mean, so which column will get first, which column get last? So if it probably doesn't matter. So I never have come to a situation where this plays any significant role. And I even can't imagine it could.
Into select star?
Select star, so never use it. So yeah. But someone can. So I guess it goes back to testing your external interfaces. So yeah, I can say for sure. So it's easier for such thing. It's easier to talk with your clients, to talk with your users, so that they don't use it. Prohibit this. It will save you so much time. So yeah.
Instead of trigger to capture it and then put it to the easiest way. If you have, let's say they say into select star common scenario.
So we also have, I will repeat on the mic, so that we can have instead of trigger that will capture such events and will rearrange. But I would say never do this. So never allow your clients. It's easier to forbid them such things. So let's move on about fragmentation. So yeah, you really need to think about this because Paul Randall, a few years ago, took a survey about how much of the pages are usually, how pages inside SQL Server used all around the world are filled. And he found that usually it's around 70% only. And I can say that if you, if you are only 70% full, so you go more, you can easily increase, again, memory utilization in real numbers. So I guess the most common scenario will be that you have page fill around 55, maybe 60%, and you go not to 90, it's optimistic, but 80 is really really nice picture, but you will still have like 45% of more memory utilization. Yeah, it again will make your queries faster. But I also have another story on fragmentation topic. So imagine I was working with a terabyte. It was pretty small, around 3 terabytes in size. And so I was asked to predict a growth and resources for that database. And I found that the growth was in such a way that we need to buy a new storage in a year. And if you work with cloud, so you have storage elastic, it's simple. But if you work on-prem, you usually buy storage in appliance. So much of the disks at once. And if you come to an end of the whole appliance, every terabyte for you will cost a new appliance. Not a few bucks, but the whole appliance. So, and that could be, in some way, the step could be very expensive. And this was the case for this database, and I started to investigate. And I found that most of the data inside the database was in 3 tables, which each of them were around 600, 800 gigabytes. And the fragmentation was around 60, 70% only. It was quite easy to achieve more on such databases. And what I found else is that free space inside database was only 400 gigs. And the tables were created with default values for the index, and fill factor default is 100%. And if you try to reorganize index, that will be even worse because the splits will go inside, and we will have like 50% after reorganize, 50% utilization. So rebuild, you can't do it because you only have 400 terabytes inside database, and you need at least 600 for the smallest table because the rebuild will create a new structure for you. You can rebuild by partition, but if you created a table with partitions in advance, if not, you're stuck. And the only solution for this problem was to create a new partition table around this, a view above 2 tables, and slowly move data one by one. And create a nice fill factor of around 80, 90%, and rebuild by partitions these tables on scheduler, and that helped. But if you plan in advance something, if you know that your tables will grow much, try to create partitions in advance. Try to think about fill factor in advance also. That's a huge topic when refactoring databases. So write new code is easy, but sync data is hard. So you have pretty much a lot of options to move your data. If you have an option, if you have a maintenance window, and you can do a one-time bulk load data movement, you're lucky enough. So it's easy. The hardest one I did many years ago. I still remember these. I needed to refactor a huge table, and I decided to do a one-time movement that way. And I prepared in advance. I took the longest break where company didn't work for 3 days because of holidays. We created a new server with special configuration just for running one query to move the data, and it lasted 3 days. So, yep. This query was completed 2 hours before company was opening again. Everything was under control, but yeah. But usually it's impossible. So, and you need to do some kind of gradual data movement. So you can use triggers again. So instead of triggers on views over the tables to move the queries to a new one, and so on. What I found works pretty nice, that we will discuss this more on the next slide, is that almost any database can have some kind of bulk load options. So SQL Server has these. I work with Cassandra and StyleDB. NoSQL Server, they also have a bunch of things that works nice. And you can load the data by batches, do a huge work, and then replay recent events. If you have a queue before your database with events, and you can replay to sync, something like restoring transaction log, but this work. And some kind Also connected with this is parallel run. You run two databases at the same time. So so both feeding data, you write in several databases at once, compare them, and then switch to one or another when you're ready. Quite nice if you have a unified data load and processing mechanism is that you, for example, you initialize and you consume your current data in the same way. So you have an application which just load events inside your database. And to initialize the database, you can just throw a whole bunch of events into this queue, and this thing will automatically load this in a nice way. That works well if you have this, but it's probably slower than the third point, just bulk load the whole data and then replaying only the recent one. So, and while moving your data, don't forget that when you delete and move, so you will leave a lot of ghost records inside your pages. Don't forget to use a page log hint. So that's if you remove all the rows from the old table while inserting in the new, the query will remove the page itself, the empty page, will not leave. Because if you don't do this, this query will start running slower, and forever. Yep.
What would you say about disabling ghost records cleanup, because that would be doing?
The question was disabling ghost run. I've never done this. Actually, don't see any reason for this. So I came to different things with ghost records, but I usually came across, so like with Puglog, usually helps a lot. And yeah, I guess these other things are not really as well as this one. The
Try to delete millions of rows with the ghost record cleanup. It was way too slow.
but did you use PageLog?
No.
No. Yep. Yeah. You try it. This is the best solution, I guess. So I tried 2 or 3, but this one works better. And what about parallel run? Yep. Yeah, sure. So the point was that we need an index on insert data, of course. Yeah, sure. So otherwise, yeah. So I try to keep information smaller on the sites, so remove extra and assume this. You understand this also. So thank you for the comment. And so let's talk about parallel run a little bit. So again, imagine you have a database and an application working with your database. So we have a question also from the online regarding moving columns to separate table. Isn't that something that can be achieved with proper indexing, not to change the logical model? So yeah, you can achieve this by proper indexing if you have covered indexes. Well, really nice column, because when you work with tables, really for Optimizer is working with indexes, not the tables. So, but the problem will be with, and yes, you can skip the logic and create separate indexes. It will cost you storage, of course, but there are some kind of complex queries, and if you still consume the data by clustering key mostly from your data, so it doesn't matter remove your column or not, so the data will be cached because on the all pages contains all data. So about parallel run, returning. So imagine you have an application writing to database, So how can you create a separate copy with probably different structure, whatever. So first, you can split things that are coming to your database. So you can push reads directly to your database, but writes you can push in a separate event log queue. And if you have this one, you can easily have it to initialize other databases. So you can run in parallel as many of them as you want. You can run Microsoft SQL as your main database, Postgres as your backup database, some kind of NoSQL with different schema on the other side. Of course, you will need some kind of external tool to compare this data because this will be in different structures. But if you really want to migrate from one structure to another or to different database engine, this pattern will work pretty well for this. And we're moving to an application API, which also helps a lot. So if you have some kind of application over your database, that also helps a lot with refactoring. Because you have lots of things, so lots of benefits. So to make your API an application resilient is easier than to make a database resilient and high available. So you can have a whole bunch of things as an advantage. For example, a small lookup tables you can keep cached inside your application and do joins on your application, for example, not on your database. Probably it could help. You can use external caching for your queries, which also is to lower the load for your database. And the main benefit is that you turning your database into a single application database. It means that only one application is working with your database, no other external clients, and you can do whatever you want with the engine inside itself. So because all the clients are outside of your database. So it's easier to refactor. And for example, I have an interesting story on this also. I created such service, and it was running on SQL Server first. So I was running an application, and then I decided to try an Apache HBase for this. And guess how much time it took me before I decided this, to a moment when on development environment, a new version of the application started to work with HBase database, consuming data. So it was it was a simple database with only like 3-5 tables and only simple crude operations on these, but it took me 35 minutes only. I know that it's a little bit cheating because there was a SQL layer above HBase database, Apache Phoenix, so I just moved the queries. So I just changed inside my code, I just created another class and changed the driver from SQL Server to whatever, Apache Phoenix. So I didn't change the queries at all, so I just created the structure. But I was running in dev environment in 35 minutes, so yeah. It also can be. So to change further, I also moved further this application to Apache Cassandra, and it took me a couple of days to rewrite the logic because it has different schema I need to take into consideration. But still, it's pretty much could be done. So I know that what I will say next, I will probably, someone can throw something on me. Yep. But I found that foreign constraints on large databases really works bad. And I usually disable them for performance reasons, but I keep them with no check option, just to know by myself that there is a constraint. And yep, if you do this, you need to ensure the data quality by different means. So if you have good tests integrity data checks and so on periodically, you can do these, but only for real serious performance problems if you do. But check constraints are good. So also consider splitting databases because it's becoming too large. Probably a lot of logic inside. You can do. You can split these simply and continue to grow each database further. So, yep. You can have two approaches here. First, split database, then change your application and split your application, for example. And the second approach would be change code first and then change database. So remember, for these scenarios, for example, synonyms will work great that call other databases. So never do at once. So step by step, remember. So, and also, yeah, there is a pattern. Also, all refactoring patterns that are for normal applications, all books on refactoring works the same as in database. So, yeah, if you decided to move, consider moving, splitting your database feature by feature, not all at once. So, and the last lesson learned, and we also have a couple of stories, is my favorite one, guess, remove data, unused data, and use structures. This is the easiest refactoring you can do, and the most hard at the same time. The easiest one is that you don't need developers for this. The hard one is that you need to negotiate with business users a lot on this topic, but it's fun. You can drop many things. So you can drop indexes, you can drop columns, you can drop tables, you can delete some kind of data. So, for example, for indexes, probably who used sysdmdb index usage stats, DMV, for finding unused indexes and remove them? Who found it useful? Less people, what I assume, yeah. They can tell you that index is completely not used, but they won't tell you more interesting patterns which you need to investigate by yourself. So for example, I have a story on this too. I had a huge table, 100 billions of rows, almost all the database, 90%, 80% of the database with this table, heavily used. And there was 2 indexes on these for finding only 2 columns on this database and 2 indexes, finding one column by, second column by first, and first column by second. And I found that one index was heavily used by the users. And the second index, I tried to find who used the second one. And when I did the research, I found that only two users were using these. The first, the process which removes the data from the database. And the second process was external users, which sometimes, very rarely, needed to find out the data. And I talked to them, so are you okay if your queries will run not in seconds, but in minutes, tens minutes? They said, yeah, we run it, okay, half an hour. We run it monthly, 2 months, 3 months scheduler, so it's okay. Okay. And I changed the pattern of removing the data to scanning, and that helps to remove the index completely, and it was like 40% of the database. So 40% is pretty huge number on, it was several terabytes. So the next thing is that this couldn't be found easy. Column, unused column couldn't be found easy, but if you work with the database, you write code, sometimes you can think, who is using this column? And you can find columns which are not used by anyone, usually, and remove it and benefit from it also. But if you have tests, again, you can drop column and check if everything right. If everything works fine, yeah, that's fine. Tables. I have only one story on this. I was able to find a table which is more than a terabyte in size in one database, which was not used by anyone. I was able to find this also. Yeah, you.
How do you know if a table is not used? Is there any feature which you can kind of activate, like a query store, which kind of tracks users for procedures, views, tables, and so on and so forth? And then after 6 months, you come in and say, okay, this view has never been used in the last 6 months.
So yeah, how do you find the table is not used? So yeah, this is easy. Sees the MDB index usage stats. So we'll tell you the information that the table that will first sign. So and again, you can think of your code if you know your workload, if you know your users of the database, you can talk and define that the table is not used. But the first one will be easiest, sees the MDB index usage. They will find this way. Another question? So. X event, so yeah. Rename the table also. Yeah, before deleting it, rename the table. So keep it for half a year and then throw away. So the last point is about data. So again, I found not 2 years ago, research says that, and from my experience, it's pretty much accurate. About 30–40% of the data inside database could be not used. And yeah, it's hard to negotiate, to talk with business, to remove something old which is not needed, which probably doesn't benefit from keeping this. Of course, you have financial organization and you keep transactions of your clients, they will never be removed. But anything else, you can. So yeah, and I have 2 stories again for you, and you will probably run out of time. About optimizations. So let's keep. So imagine that you have that you are running a, let's say, pizzeria, online pizzeria, and you're keeping a client's table, a pizza's table, and you in the middle there is a table which associates what pizzas each user likes. And the left and right tables could be not large enough, probably millions of rows, hundreds of rows, but the middle table could be billions of rows. And imagine you need to calculate some kind of algorithm based on what kind of pizzas user like. You need to calculate maybe special offer for him, a discount, whatever. And calculation of this table can be really huge. But if you analyze this, you will usually come up to a situation that there is not so much distinct groups of pizzas user like. So because if someone likes pepperoni, they will probably like something similar to pepperoni and whatever. So, and if you put such sets in the separate table and create associate with the set for the user, it's much harder design to work with, but it saves a lot of time. And to recalculate, for example, special offers will only take you to scan on the sets table, which is way too smaller comparing to the original one. If you know objective-oriented patterns, if you have this is flyway pattern, you also have it, nothing new. And another last probably thing is data exchange. Also, I was once working with a database on a distributed system, 2 databases exchanging data, and I found that most of the data coming was JSON files between SQL servers in n varchar column. And when I started to investigate, I found that no Unicode files no Unicode symbols were inside this data, and I converted it to a simple varchar. And it helps me to push twice as more data on the same things. So it's the lesson learned here. So it's choose your types correctly always. That can help also for performance. And yeah, I have a book for you to recommend. That was written. So we're around out of time. So it was written 17 years ago. 17. I read it recently, and it's quite nice. It still has all the information inside this book is pretty actual. So if you start, but this is introductory to refactoring. So if you're new, I can highly recommend this book to structure your knowledge to this. Yeah, and that's it. So I don't know. We have lunch next, but I can stay, and if you have questions, I can answer. Or if we can stop, I will also available after the session. You can come and ask questions. So we have.
Yeah. The whole idea is okay. Like we all understand, like you can do these bits in there, like in terms of performance achievement and database side in there. But what about the bespoke application? We have the third-party applications and some highly dependencies of other application side of it, which you can't really do these kind of tweaks. So you can obviously give them suggestions, but you still have to manage and maintain these performance issues, because I am in a situation where all these problems exist and I don't have any much choice in there, basically, rather like do some partitioning and those kind of things in there.
So yeah, the question was, if you control the code of the database, it's easier. So, but if you have already application running, third-party application running, so yeah, this kind of not this session about. There's a session about changing. So, but for your scenario, the only thing which is left is probably use some kind of things that will smoothly keep your queries running faster. For example, you can inside SQL Server you have materialized views, which you can build. Always such kind of intrusions into some third application is quite challenging, because you don't control the code of the application, and you do some kind of hacks, and sometimes they can broke if the application changes, and you always in a very hard. It's hard, yeah. But all you can do is create some workarounds. So for me, for example, I once came to a situation where Visual Studio didn't work with my SQL Server because it sends queries to information schema inside SQL Server, very bad queries. And what I can do with this? I was able to fix it with the with the hints, with the plain hint created in such database, but it always some kind of things that could in next version could stop working. So, but it's hard. So, thank you. I guess that's all. If you have questions, feel free to come and feel free to leave a feedback. I will really appreciate it. So, thank you very much for coming, guys.